Okay, we're going to work on evaluating logs. Okay. Go away. So we have this formula here as log. Actually, let's focus on the exponential one to start. Y is equal to x to the power of a. Okay, pretty straightforward. We've seen this written before. The equivalent in log form, okay, with these same terms, okay, would be log x. So the base then becomes the base of the log. The answer becomes what the log is 2, so our y value, and the exponent is what it's all equal to. Okay, so I'm just going to highlight these with respect to each other. So the x is here, the y is there, okay, and the a is here. That's how they relate to each other. So an example of this would be, first off, let's say we just put 2 to the power of 3 is equal to 8. Okay? Well, the equivalent in log form would be log 2 to 8 is equal to 3. Okay? And the reason being for this is, if you remember our, whoops, other one went to yellow. This is our base, so our base 2. Our power is the answer in the log, and our answer for the exponent is the log we're using, the number. All right, so that's how they kind of relate to each other. So we can use this information to help us solve for logs. In other words, what we're saying is we can go back and forth between log values and exponential values to make things simpler to solve. So they've given us a very straightforward question to start. We'll call this example 1. Log base 4 to 64. Okay, so they want you to evaluate this. In other words, what is that going to be equal to? Now, as we go along, we might get really good at trying to solve this, but what I'm going to do is I'm just going to convert this. I'm going to convert this to my exponential form. Well, in my exponential form, we know that this, do it yellow, this is the base, correct? So our base is going to be 4. We know that our exponent is technically the answer. So our exponent is going to be x. So we're going to be solving for whatever power. And our value for y is what it's equal to in the exponent. So that'll be our 64. So now I can think of this a little more in terms of what I'm used to working with. 4 to the power of what is equal to 64? Do you happen to know?
Is it 6, 7?
Well, if we did 4 to the 7, I'm going to tell you right now, it's a huge number. 4 to the power of 7, 16,384. So let's start off really simple. What is, 4 to the power of 2?
It's 16.
That's right. So 4 to the power of 3 would be 16 times 4, which happens to be 64. So what is the x value here? X is equal to 3. Exactly. Okay. So we've used that there. I'm going to use another one just to show you a radical form. So let's say we have log 5 and then root 3 of 25. Okay, so this is our radical form here. What they've done here, same idea. Let's go on converting. So our base is 5. It's green at the end. Our base is 5. So in this question, we're going to be to the power of 5, or sorry, base 5. We know we're trying to solve our answer here, so that's going to be our unknown. In other words, that is our exponent in this question, our unknown when we're evaluating this. So this will become our unknown, which is x. And this is all equal to our y value, and our y value happens to be root 3 of 25. So root 3 of 25. Okay, well, one way I might want to go about solving this, now that I'm in specifically exponential form, so I'm just going to focus on the right side of this right now, is I want to get them to the same base, okay? And that's the same way I could have done 64. How can I turn 25 into a base of 5?
5 power of 2.
5 power of 2. So let's go 5x is equal to root 3 of 5 to the power of 2. Well, how can I rewrite root 3 as an exponent? Do you know?
As a fraction.
That's right, as a fraction. It becomes what fraction specifically?
1/3.
1/3. So what this says is 5x is equal to base 5, 2 times 1/3 in the exponent. So what's 2 times 1/3?
2/3.
2/3. So 5x is equal to 5 to the power of 2/3, which means x is equal to what in this question?
2/3.
2/3. So that was our unknown, or our answer in this question. Okay. So that's how we can relate it to a radical also. Okay, so we've done a simple and then a complex version.